Hello, welcome to this session on trig equations in radians. We're going to look at solving three equations as examples. Number one here, cos of theta minus pi equals root 3 over 2. So that's going to involve a translation. Here is number two is a stretch. Sine of 2 theta equals root 2 over 2. 3 is a quadratic trig equation, and that's going to involve using an identity. All of these skills we remember, I hope, from year one, but they just involve radians. Okay, let's look at the first equation. Now we're going to change this. Our strategy is to change it to cos of x equals root 3 over 2. So we take away the complication. So, well, what does that mean? Well, x is equal to theta minus pi, and we can say theta equals x plus pi. Let's think about what we're dealing with. We're now solving it in x. So x is going to be between, well, 0 minus pi, so negative pi, and 2 pi minus pi, pi. Quick sketch of the graph will help us. So there we go. But remember, pi, negative pi, positive, negative 180. And that is the cos graph. So let's solve it. We're solving cos x equals root 3 over 2 between negative pi and pi. So let's have a look at that. Well, what's our principal solution? Our principal solution is pi over 6. Pi over 6, which is here. There we go. Think about the symmetry there. That other solution has got to be, let's make that a little bit neater, it's not writing very well. There's got to be negative pi over 6 because of the symmetry around 0 with the cos graph. And we can see in the range of values for x, there are no more solutions. So we just adjust our values to get our solutions to the actual equation. The actual equation back up here. There we go. Well, theta is x plus pi, so we just add pi to both of these. Here we go. Well, negative pi over 6 add pi would be 5 pi over 6. And pi over 6 add pi would be 7 pi over 6. So here are our solutions. There you go, two solutions there. And hope that one's clear. Let's move on. Okay, let's look at solving our second one. Let's say, okay, sine of x equals root 2 over 2. So what am I saying? I'm saying x is 2 lots of theta. So theta, 2 lots of theta, theta equals x over 2. Well, what are our values for theta? So theta was between 2 pi and 0. So x is going to be between 4 pi and 0. So let's look at the equation next. X is root 2 over 2. Our principal value is going to be pi over 4. Let's remind ourselves of the graph of sine 1, -1, up and down, up and down, down and up and down and up. And that's going well, there's pi over 2 is there, pi over 4. Look at the symmetry. There's our solutions. And hopefully, using the graphs, it's always the easiest way really to find your multiple solutions. You've got pi minus 1/4 pi, so you've got 3/4 pi. Then then it's negative down here, so we're not really interested in that in this case. Then we look over between 2 pi and pi. We've got 2 pi and 1/4, which is 9 pi over 4. And then we've got 3 pi minus 1/4, so that's 11 pi over 4. Well, what are our solutions then? Remember, pi is x over 2, so I divide all these by 2. So I've got theta must be pi over 8, 3 pi over 8, 9 pi over 8, and 11 pi over 8. And that gives us our 4 solutions. There we go. 4 solutions to this problem. So simply changing the variable from 2 theta to x helps. And then at the end, we put everything back into theta. Okay, let's solve this quadratic trig equation. I've got a quadratic, it's in cos and sine. I want to put it into either cos or sine, just one of those. So let's change this. Let's change cos squared into sine squared, or more precisely, 2 lots of 1 minus sine squared theta plus 3 sine theta equals 3. So that gives me 2 minus 2 sine squared theta plus 3 sine theta equals 3. Now, I like a quadratic to have a positive coefficient for the squared bits. So let's put everything over to the right-hand side. So it's going to be positive 2 on the right-hand side, positive 2 sine squared theta minus 3 sine theta. And we've got plus 1. There we go, I believe. Oh. Right, there we go. Okay, let sine theta equal y. So 0 equals 2y squared minus 3y plus 1. That factorizes, of course. So we've got minus 1, minus 1. So, well, y equals a half. Y equals 1. So sine theta equals a half and sine theta equals 1. Quick look at our sine graph. There we go. Pi, 2 pi, minus 1 and 1. Well, that's going to give me, sine equals 1 is clearly going to give me theta equals pi over 2. sine equals a half. Well, that's going to give me theta equals pi over 6, which is here, and pi minus pi over 6, which is theta equals 5 pi over 6. Two solutions here. There's no negative values here to deal with, so we just need between 0 and pi. Okay, hopefully this makes sense. Thank you very much.